Welcome to your first Algebra 1 video lesson. Today we are talking about quadratic vocabulary and then some domain and range. Okay, remember from last semester that quadratics are these U shapes. The second one is an example of an application, which is typically things flying through space, such as a soccer ball. All right, go ahead and pause the video and copy down these vocabulary words. Welcome back. At the top of the page, you will see the equation for our quadratic. This is called the parent function for quadratics. This just means it's the most simple equation we can have and still have it be a quadratic. Now, the thing that makes an equation quadratic is having x squared, or to the power of 2. Our next vocabulary word is parabola. Parabola just means that you have a graph that looks like a U. Now, it could be a happy face U or a sad face U, but it's never going to be a sideways U. That is not a quadratic or a parabola. Next, we have the vertex, which is the center point of our parabola. Now, if you look at the graph to the right, our vertex is labeled in purple. It occurs right in the center. And if we look closely, we see that our vertex occurs at -1, 2, 3, 4. Okay, so the vertex is always going to be a point. The next vocabulary word we have is max or min, written out as maximum or minimum. Now, each parabola has either a maximum, such as this one, or a minimum, such as this one. Depends on if it's an upside down U or a right side up U. In the case of our quadratic to the right, we have a maximum. Now, maximums and minimums measure height. So all we care about is how high or how low our parabola goes. So if we look at our vertex, the height there is actually just 4. Okay, now this 4 matches always with the y value of our vertex. So if you ever have a hard time, just check out your vertex point. All right, our next vocabulary word is y-intercept, which you should be familiar with from dealing with linear equations and y equals mx plus b. And just like before, this is where our graph crosses the y-axis. So this is labeled with a red dot on our graph, and we see this occurs at 0, 3. Now, just as with linear equations, our y-intercept occurs when x is 0. Speaking of x, our next vocabulary word is x-intercept. Now, you'll notice for our x-intercepts, we also have the word roots, zeros, and solutions. Those all mean the same thing, so if you're asked to find the root of a parabola or the solution to a quadratic, all of those just mean find the x-intercept. Now, just like with linear equations, an x-intercept is where our graph crosses the x-axis. So you'll see this happens 2 times here, and it's labeled in blue on our graph. So we have an x-intercept at -3, 0 and at 1, 0. Now, just as with linear equations, our x-intercept occurs when y is equal to 0. The different thing about x-intercepts now is we can have 0 of them if our u occurs somewhere above or below the x-axis and never crosses it. We can also have 1 solution if our quadratic crosses directly on the x-axis, or we can have 2 solutions, as you see in this graph. Okay, so keep that in mind. There could be 0, 1, or 2 solutions. Our last vocabulary word is the axis of symmetry. Now, symmetry, as we know, is where something reflects. So this is the vertical line that splits our graph directly in half. So the axis of symmetry is actually the equation of the line that splits our parabola. So in this situation, we see that this line crosses x at -1, so our equation is x equals -1. All right, so we have a practice problem right here. Go ahead and pause the video and try and find these 5 important features of our parabola. All right, I hope you had a good time finding those things. Go ahead and check your answers to make sure you understand how to find these things. All right, our next section is talking about domain and range. Before we can talk about domain and range, we need a quick review of interval notation, which is just writing the solutions for graphs of inequalities using those parentheses, brackets, and infinity signs. Okay, so if we look at this graph, this is a graph of x is greater than -4. If we're writing our answer in interval notation, we see that the farthest left we ever go is -4. And if we continue to follow our graph, the farthest right we ever go will be infinity. Now we have to decide if we want to use parentheses or brackets. Since we have a hole at -4, you cannot stand on it. So we put a round parenthesis. Similarly with infinity, if you think you've gotten to infinity, you can just keep going. So this is also going to be a parenthesis. Now we're going to apply this concept to two-dimensional graphs. So let's go ahead and use interval notation to define this parabola. Now domain is the first part we need to learn about. Domain is all possible x values. So the way I like to think about this is this little stick guy Jim. Jim likes to go for walks on graphs. Now when we're talking about domain and range, all he cares about for domain is going to the left and going to the right. So Jim is going to go for a walk. He's going to go as far left as he ever can in this graph. Now don't get confused. This graph continues going forever and ever. So Jim's going to keep walking and walking, and ultimately he can go all the way to the left until he gets to -infinity. Next, Jim is going to go for a walk to the right. So he's going to follow his graph to the right forever and ever and ever. And again, he reaches infinity. Now, just like before, infinities have round brackets, so we just found the domain of this graph, which is all possible x values. Now, lucky for us, Jim can also find range by talking about up and down. So Jim says, I wonder how far down I can go. So he follows this graph to the lowest point, which is -infinity. And then he follows this graph to the highest point. Now, unfortunately, this is as high as Jim can ever go. So for this situation, the highest point is 4, because there's just no graph above 4. Okay, now on 4, it's not an open dot. There's nothing weird going on, so he can stand on 4. That gives us this bracket, and we just found our range. All right, so we have two examples here. Go ahead and pause the video and see if you can find the domain and range of these two graphs. All right, for our first example, we're going to picture Jim going for a walk to the left and to the right. You'll see that he can go to the left forever and to the right forever. So our domain is -infinity to +infinity. Next, we want to picture Jim going for a walk up and down. We see the lowest point he can ever get to occurs right here at 0. And the highest point he can ever get to is infinity. All right, this graph is not a quadratic. It's kind of a special curvy thing. But we can still find domain and range for it. So here we've got Jim going for his walk. The farthest left he can ever go is 0. He cannot continue past that point because it stops at that dot. Okay, now the farthest right he can ever go is 7. He can stand on both of those dots, so there's my domain. Now we can look at again, going up and down, and we see that the lowest point he can actually get to occurs right here, and the height of that point is -2. So that's the lowest point he can get to. The highest point occurs here at a height of 4, and again, he can stand on both those points. All right, that concludes all of your lesson. Tomorrow in class, please bring the answers to these 7 things. We will go over them in class for a grade. Good luck.